Okay, question 2. A cyclist travelling on a level road at a velocity of 8 meters per second. Her legs provide a forward force of 150 newtons. How much work does she do in 10 seconds? Okay, t equals 10 seconds. So we know a velocity, we know a force, we need to calculate work, and we know a time. Now the equation for work is force times distance. We don't need to actually consider the angle in this case because they're in the same direction. But we need a distance and we don't have a distance. However, we have a speed and we have a time. Remember, velocity equals distance over time, or distance equals speed times time. So we can work out the speed, which is 8 times 10 seconds. So the distance covered is 80 meters. And now we can go ahead and work out the work done. And that is 150 times 80 equals 12,000 joules. Okay. Okay, question 7. Tennis ball of mass 60 grams is dropped from a height of 1.5 meters. It rebounds but loses 25% of its kinetic energy in the bounce. Ignoring air resistance, calculate the velocity with which it hits the ground. Now this is in actual fact a SUVAT question. So ball is dropped, so u equals 0, x equals 1.5, v is what we're trying to find, and the acceleration, I'm going to say down, is positive. The acceleration is 9.81. So let's have a look. Can't use v equals u plus at. V squared equals u squared plus 2ax. So u is 0, so that's 0. 2 times 9.81 times the distance, which is 1.5. So we have 2 times 9.81 times 1.5 is 29.43. And v is the square root of that. So square root 29.43 is 5.4 meters per second. Okay, that's part A. Okay, next bit, part B. What's the velocity at which it leaves the ground? So if it loses 25% of its kinetic energy, well, this is the velocity at which it hits the ground. So let's work out the kinetic energy with which it hits the ground using half mv squared. So that's a half times, what's 60? Let's just do 60 times 10 to the minus 3 to turn that into kilograms. Times 5.4 squared. So the kinetic energy that it hits the ground with is 0.5 times 60 times 10 to the minus 3 times 5.4 squared. It is 0.87 joules. Okay, that's the kinetic energy it hits the ground with. We need to know the velocity at which it leaves the ground. So the question told us that it loses 25% of that kinetic energy. So if we're losing 25%, we're left with 75%. So 0.87 times 0.75 is 0.66 joules. So that, for part B, is, oh no, that is the kinetic energy with which it leaves the ground. If that's the kinetic energy, what is the velocity? So if that's the kinetic energy and the mass is 60 times 10 to the minus 3, what is V? So we have E equals a half mv squared. V equals the square root of 2e over m. And if you substitute your numbers in there, 2 times 0.66 divided by the mass, which is 60, 10 to the minus 3. That is the square root of 22, 4.7 meters per second. Okay, that's part C. Okay, last bit. The height that it reaches on rebound. So let's assume that all that kinetic energy is converted into gravitational potential energy. Okay, so if we had 0.66 joules, that becomes mass times g times h, which is the equation for gravitational potential energy. So now we can rearrange that to give us h equals 0.66 over mg, which is 60 times 10 to the minus 3 times 9.81, and that should calculate 1.1 meter. Okay.